Alright guys, let's do number 43. I really like this one. A daring ranch hand sitting on a tree limb wishes to drop vertically onto a horse galloping under a tree. The constant speed of the horse is 10 meters per second, and the distance from the limb to the level of the saddle is 3 meters. Alright, so let's just visually think about it. So this is a pretty nice problem. So you have a horse that's traveling at a speed of 10 meters per second. And you have the distance from the limb to the level of the saddle is 3 meters. So the horizontal distance is 3 meters, right? I think that's what it means. Yeah, they're from the level. Presuming like, the vertical height. In fact, let's kind of fix this equation a little. Let's put this a little like that just to make it a little clear. Because it's going to land on the saddle. So, folks, what must the horizontal distance be between the limb, between the ranch hand makes it move? So, right when the horse starts moving, he's going to travel at some distance, which is going to be the velocity times the time it takes. That time it takes is the time it takes for where if they were to land right at that spot, it would take the time it takes for this guy to drop down right at that initial height to that point. So the motion graph is going to be the t-axis, and then this is going to be the y-axis, and it's going to drop at some initial velocity, and since it's dropping, it's going to look like this. We're going to find that specific time it takes for the y to be 0. So the motion is basically this, folks. It's basically going to be y being some initial velocity, which is 0, some initial position, which we're going to call h, minus gt squared over 2. G being 9.8 meters per second squared. So notice, folks, that this is actually pretty straightforward once you got the hang of it. So the question is asking, what must the horizontal distance be? What is this specific x that we're looking for? So in order to find that, let's find the time it takes for h for this to be 0. So we're going to take that h2 divided by g, square root the thing, and boom, there you go, there's the time. So the time it takes for the guy to travel towards the ground, to fall towards the direction of the saddle, is going to be 0.782 seconds. So now all we have to do is find the horizontal distance, being the constant velocity, which is 10 meters per second, times the time it takes, which is 0.782 seconds. Or in this case, this is going to be basically the same equation. So we're just going to take that equation that we find, we're going to multiply that by 10, which is, that's just saying moving to one decimal towards the right. Once you find that, then x is going to be 7.82 meters. All right, let's see what part B is asking for. What time interval is in the air? Oh, we just solved for that. Okay, well, we did a little backwards, but okay. So the time interval is basically that equation that I set up for you guys. So 0.782 seconds. That's all, folks. Notice that it took me very easy to solve this problem, even though it's blue and then the other one is black. It turns out that people really do indeed memorize, as opposed to they just plug and chug. And they just memorize the equations and plug and chug the thing. Plug and chugging rather than actual understanding. But if you really do understand this should be pretty straightforward for you guys, and I hope it is. Because believe me, folks, I want smart people on my channel. I don't want to live in a generation of engineers where we just memorize for shit and don't know what we're doing, folks. That doesn't sit well with me. I hope we can move beyond past that. All right, folks. Goodbye.